Alright guys, so welcome to the first part of this virtual percent error lab with these M&Ms. In this first part, we are going to find the mass of our box of M&Ms. Now, on this box, if we can read this, it does say 87.9 grams. That's how much should be in this box. And the first part we're going to do is see if that is correct or not. So I've got a food scale. Now granted, this is not as precise as our chem lab scales are, but for now it will have to do. So we're going to put a dish on here first. And we're going to zero our scale so we can put these M&Ms in there and they don't go all over the place. So let's pour them in, see what we get. All right, so I have we're going to say 90 grams. So it looks like our box here says 90 grams. Again, it says 87.9 on the box. So, you know, it's close, but we will calculate our percent error from that. So write down that number on your sheet and we'll do our percent error calculation here in a second. All right, so the next part of the lab here is we're going to take all of our M&Ms, we're going to sort them out into all of the different colors, so red, orange, yellow, green, blue, and brown. And we're going to determine if the percentages that are given to us on our handout are accurate to what we actually have in our box. So let's do some sorting. Here we go. This might take a while, so I might speed this up. Alright, so we have sorted all of our M&Ms and we are going to count each one and we're going to record these in our data table. So for red, we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 red M&Ms. For the orange ones, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 orange M&Ms. For yellow, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 yellow M&Ms. For green, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 green M&Ms. For blue, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 blue M&Ms. And last but not least, for brown, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 brown M&Ms. So we are going to record all of that data in our data table, and then we are going to go from there. All right. Also, if we add all of our total M&M colors together, we get a total of 102 M&Ms in our entire sample. So we are also going to write that down in our data table as 102 for, again, our total number of M&Ms. Taking the total number of M&Ms of each color, which again, for red we had 11, orange we had 19, yellow we had 19, green we had 20, blue we had 24, and brown we had 9. We are going to now calculate using the percentages that the Mars company has given us and try and see how many reds, oranges, yellows, greens, blues, and browns we should have in our box based on the percentages that the Mars company has given to us or that is on our sheet. Alright, so take a look at the percentages, see if you got the same numbers that I did. And if not, that's okay. You can adjust your numbers. So the question now we need to ask ourselves is this acceptable? Is our numbers that we counted in our sample acceptable based on the numbers that the Mars company told us we should have based on their percentages? So we're going to answer that question lastly in our data table.
All right, so we're here for the PostLab questions now with the virtual percent error lab. And I have all of my numbers here written in my data table. If you don't have yours written in like this, this is how it should look. You should have answered these questions here in this far right column of whether or not the number that the Mars company has given us compared to what we got, is that acceptable? For most of these, I would say yeah. If the Mars company says you should have 13 red and we got 11, that's fine. You know, if we should have had 20 orange, we had 19, that's fine. You know, 14 yellow, we had 19. Just based on percent error or accuracy, I'd say it's not acceptable. It's a little bit too far off. You know, we're supposed to have 16 green, we had 20. Again, too far off. 24 blue, spot on. That one was spot on. And then we were supposed to have 13 brown, and we had 9. So, again, this is sort of just personal preference. There's really no right or wrong answer per se. So let's answer these questions here at the end. So the first one, it says, we're going to make a bar graph depicting the percent error for each color. And it says, draw one given in the space given. Now, we can't really draw on this very well because it's a Google Doc. So I'm going to make my bar graph on paper. So I'm just going to switch my camera here. If you have, you know, a piece of paper, just do it on paper. You can just leave this part blank. So it's no big deal. Let's just switch over here real quick. Perfect. There we go. All right. So we have this piece of paper here in front of us. And I'm just going to make some bars. I guess we'll go red, orange, yellow, green, blue, and brown. Bottom will have 0, and this is percent error. And at the top we have 100%. All right, so we're going to make some bar graphs of our percent error, which means we need to do these calculations out. So let's do the calculations for percent error. How we're going to do that? We are going to take our number of reds that we got, which was 11, minus the number that the Mars company told us we should have had, which was 13. We'll take the absolute value of that. So if it's negative, we'll take it as a positive. And we're going to divide that by the total number that the Mars company said we should have got, and then times that by 100. So let's do this real quick on a calculator. And we have 11 minus 13, which is negative 2. Divide that by 13, and then times it by 100. And we have a total percent error of 15%. So let's just go up by tens, I guess. So we'll go 50%. We'll go 10, 20, 30, 40, 60, 70, 80, 90. So 15% would be about here. So draw a bar for 15%. So there's our percent error for our red M&Ms. And then we're going to do that calculation for all the rest of them. So pause the video and do that now. All right, so I have finished all my calculations. I've made my graph. So we had a 15% error for our red M&Ms, a 5% error for our orange M&Ms, a 35% error for our yellow M&Ms, 25% error for our green M&Ms, a 0% error for our blue M&Ms, and a 30% error for our brown M&Ms. Okay, so if you got the same percentages than I did, then good job. And if you did not, well, maybe do you recalculate them. So, all right, let's take a look back then at our handout to answer the rest of the questions. All right, so it says, formulate a conclusion that summarizes your data. So we can say, you know, it basically looked like the blue, orange, and red M&Ms had the least amount of percent error. The yellow, the green, and the brown M&Ms had the largest amount of percent error. So let's maybe just write something like that. So we can say the red, orange, and blue M&Ms had the lowest amount of percent error, while, let's actually zoom in here too. There we go. While the yellow, green, and brown M&Ms had the largest amount of percent error. All right. Number 3, provide at least 3 sources of error. Okay. So this one is basically asking us to think about why our M&Ms had such a large percent error. Like what could be 3 reasons why the percent error is so far off. So certainly there's human error, right? I'm sure somewhere along the production of M&M boxes, humans do stuff, and we make mistakes all the time. So one we could say is human error. Another one would be machine error, right? So I'm sure most of these like the M&Ms themselves are probably being packed up, by a machine or made or counted by a machine. And machines obviously make mistakes, so we can say number 2 is machine error. And then for the third one, other than human error and machine error, it could just be the like the math calculation. So it could be that whoever maybe calculated out the percentages and stuff for the box or for like these numbers just messed up somewhere. So we could also say error in math calculations. So biggest one's probably just human error, machine error, what I would say are the biggest reasons. So all right, is the Mars company accurate and precise? Define these words and apply them to your data. You may need to look at other groups' data. All right, well, we're not going to worry about looking at other groups' data, so let's just get rid of that. There we go. But we can answer the other question. So is the Mars company accurate and precise? So when it comes to accuracy, remember that accuracy means are the numbers close to what they should be? So that kind of is looking at percent error. Now again, if we go and we look back at our graph that we made, or I guess the graph I made, whether you made one or not, we had a 35% error at the largest amount. Now at the lowest though was 0%. So are they accurate? No, not really. But are they precise? Not really either. So the best way to answer this question is when it comes to accuracy, are they accurate? No. Okay, no. They are not accurate because they had a percent error of 35% at the largest. Okay, if they were accurate, every single percent error would be 0%. Okay, that would be accuracy, or maybe even like 5%. So no. As for precision, are they precise? Also no. And the reason, again, why they're not precise is because their percent errors fluctuate from 0 to 35%. If they were precise, remember precision is about consistency. If they're precise, then at least every percent error would be the same. So, if they were precise, it would be like 16% error for everything, like 16, 16, 16, 16, 16. Even though they're not accurate because they have percent error, they're all at least the same. They're all off by the same amount. Okay, so for precision, we can say they also are not precise because their percent errors range from 0% to 35%. If they were precise, then every percent error would be the same. Okay? All right. So, I believe that is the last question for the lab there. All right. So hopefully you learned a little bit about percent error, and that was helpful. And if not, well, I'm sorry. So if you have any questions, though, again, you can always reach out to me, email me, talk to me in class. We could do a Google meeting or something, but make sure that you do understand how to calculate percent error. And again, as always, if you have any questions, make sure you ask. So, all right, guys, I'm Mr. B. That's it for this lab. Thanks. See you in the next one.